Hello, class. We are now on to exponential and logarithmic equations. So we're going to be solving these when they're not quite as pretty as last time. Now that you know how to use your different operations, we're actually going to put those to use and solve things and see if we can get a little bit better understanding of these. Okay, make sure you have your notes out. You're on exponential and logarithmic equations, and let's go. Okay, we're going to use like basis to solve. We're going to use logs to solve, the definition of log to solve, a one-to-one property, which we'll talk about, and then a few story problems. Okay, the first thing we need to know about exponents is if the base is the same, then the exponents are equal. So right here, if I have 25 3x to the 6th equals 125, if I can get these bases identical, I can set the exponents equal to each other and solve. Well, we know that 25 is 5 squared times the 3x minus 6, and we know 125 is 5 cubed. Now that the bases are the same, the exponents have to be identical. So I get 2 3x minus 6 equals 3, and now it's just a simple solve that you've been doing forever. So 6x minus 12 equals 3, so 6x equals 15. So x equals, hang on here. So x equals 15 over 6. Reduce that by 3 and you get 5 halves. All right, it's got to start working. There it goes. Okay, we're good. Now, your turn. Like basis, you should have had this was 2 cubed to the x plus 2. You should have said, hey, this is 2 squared, x minus 3. Okay, the 2's are the same, so the exponents are equal. Equals 2 times your x minus 3. Do your distribution. Subtract your 2x and subtract your 6, so you get x equals negative 12. I hope you did a good job. All right, now let's go on. We're going to get them just a little bit harder here. Okay, when you're doing this, you have to isolate the exponential expression before you can actually do the work. You take the common log on both sides, base 10, or the natural log on both sides, whatever one you want. Simplify using one of the properties. So if it's e, you do a natural log. You bring it to the front for your exponent. Here, natural log of e is going to cancel. Log base 10 of 10 cancels, and then you solve. Okay, let's go. So now we've got 5x equals 134. We cannot get like bases. This is where logs truly come into effect, where they actually do something. So I'm going to take the log of both sides. I use log base 10. You could have used natural log too. It doesn't matter here. But since there are no e's, log seems the easier. So now I take the x and I bring it to the front. Okay, I need to solve for x. So all I have to do is divide by log of 5 on both sides. Once you divide by log of 5, you know what x is, and you literally type this into your calculator. It's your change of base formula, right? And you get 3.04. Okay, pause and try yours. I'm going to use the log. So we use log 6 of x equals log of 235. Bring your x in front. So x log of 6 equals log of 235. Divide by your log of 6. Literally type that into your calculator. So now you got x equals, and I got 3.047. All right, next we're going to show you that you can use natural log. It's up to you. So now it's the same thing. I took the natural log. You do the exact same steps. The 2x minus 1 will go in front. Now this one here is a little bit mean, not a ton. Times a natural log of 7. I need to solve for x, but it's inside these parentheses. Remember, these are just numbers. They're nothing more than numbers. Ugly numbers, but numbers. So we have to distribute. So we got 2x natural log of 3 minus, the natural log of 3 equals x natural log of 7 plus the natural log of 7. I need to get the x's on the same side. So I need to bring, whoops, this x, I need to subtract this x to the other side. So I got 2x, natural log of 3 minus x, natural log of 7, and I'm going to add the natural log of 3 to my other side. So this equals the natural log of 7 plus the natural log of 3. Now, you're looking at what they have in common. So what do these two things have in common? And the answer is x, so we're going to factor it out. 2 natural log of 3 minus the natural log of 7 still equals the natural log of 7 plus the natural log of 3. We have to divide to get the x by itself, so we divide by everything in those parentheses on both sides of the equation. Okay, you literally type this into your calculator and you should get x equals 12.11 is what I got. All right, hopefully we did well. Okay, now it's your turn. Take your time, go slowly, and figure out what you're doing. So make sure you pause this. I'm going to take the log of both sides, just so you understand we can do both of them. If you use natural log, you will do the exact same steps, just that yours will say natural log instead of log. We're going to bring down the exponent, so 2x plus 3 times the log of 5 equals x minus 7 times the log of 2. We're going to distribute the log of 5. So we got 2x log of 5 plus 3 log of 5 equals x log of 2 minus 7 log of 2. Subtract your x log 2 over. So we got 2x log 5 minus x log 2 equals minus 7 log 2, and subtract over your 3 minus 3 log 5. Factor out your x. 2 log 5 minus log 2 equals minus 7 log 2 minus 3 log 5. Now divide by your parentheses. 2 log 5 minus the log of 2. Divide by parentheses. 2 log 5 minus the log of 2. Type that all into your calculator, and I got x equals a negative 3.83. Hopefully we agreed, since I did that pretty late at night, actually. Okay, next is use the definition of log to solve logarithmic equations. So we have to remember log base b of m equals c is b to the c equals m, right? Base, exponent, answer. Solve for the variable, check your answer. So this time, since the base and the exponent are both numbers, we can rewrite. That's how we know when to use this. So 2 cubed equals x minus 4. So 8 equals x minus 4. So x equals 12. Okay, your turn. Pause and give it a shot. So now you have 4 squared equals x plus 5. So 16 equals x plus 5. So x equals 11. Let's continue on. 4 natural log of 3x equals 8. You could actually do this by putting the exponent up here, but it gets really large. So we don't particularly want to do that. We're going to simplify if we can. Since both of these are divisible by 4, we're going to divide both sides by 4. So now I got the natural log of 3x equals 2. And remember the natural log's base is e. So this means e squared equals 3x. Right? Now I need to solve for x, so I divide by 3, and I am finished. Okay, pause and try yours. So you divide it by 6. So the natural log of 5x equals 4. All right, that means e to the 4th equals 5x, which means x equals, let's move down a little bit, e to the 4th divided by 5, and you are finished. You can type it in and get an actual decimal if you would prefer. All right, next. we have like basis, which is nice. So now we're going to use what we know about logs. Well, like basis means when I'm adding, I am multiplying. So I can take x times x minus 3. Okay, this is 10. So I know 10 to the first equals x squared minus 3x when you do your distribution. Subtract your 10 over. This is a nice factor, so we're going to do that, -5 and 2, which means x equals 5 and x equals -2. Once you do this, you must check your answers because it may or may not work. So let's try the first one. Let's do the 5. So we do log of 5 plus the log of 5 minus 3 equals 1. Well, this is the log of 5 plus the log of 2 equals 1. So we got log of 5 plus the log of 2 equals 1. I know when I'm adding, I am multiplying. So I got log of 10, because it's 5 times 2 equals 1, which makes sense because 10 to the first is 10. Check. Now let's do the next one. We're going to do log of -2. I am done at this point because remember, logs cannot be negative because whenever you graph them, they go like so, right? And without a shift, it's always positive. So this is bad. -2 does not work. Your solution is x equals 5. All right, let's go here. Remember, if you have like bases, then the answers must be the same. You solve for variables and you also check your solutions on these. Okay, so I know that subtraction means division. So we have the natural log of x minus 3 equals the natural log of 7x minus 23 divided by x plus 1. All right, now that we got that done, we have the natural log on both sides. So since those are equal, we know that x minus 3 must equal the 7x minus 23 over the x plus 1. Now we got to solve. That's just getting your like denominators, right? X plus 1. They cancel. Let's do our distribution while we have it here. So we've got x squared. So minus 3x plus x would be minus 2x minus 3 equals 7x minus 23. Okay, let's put these together. So x squared minus 9x, add the 23 plus 20 equals 0. Factors of 20 that give you 9, x minus 4, and x minus 5. So that means x can equal 4 or x can equal 5. Again, you must check. So let's go up here and let's do x equals 4. So we have the natural log of 4 minus 3, 3 equals the natural log of 28 minus 23 minus the natural log. I'm running out of room, so I'm just going to put that in as 5. Well, 28 minus 23 is 5. Well, subtraction means division, so this is the natural log of 5 divided by 5. This is the natural log of 1. Whoops. All right, so the natural log of 1 equals the natural log of 1. Checks. 4 works. Let's try 5. So now I'm going to let x equal 5. So we got the natural log. 5 minus 3 equals the natural log. I'm going to run out of room, so we're going to put this in. 35 minus 23 minus the natural log of 6. Well, let's see. 35 minus 23 is 12. 12 divided by 6 is 2, so this is the natural log of 2. And this is also the natural log of 2. Check. So both of the answers work this time. Okay, pause and try yours. First thing you should have said is subtraction means division. So I've got the log of x plus 9 divided by x minus 1 equals the log of x plus 3. Okay, now that I have both logs, they can cancel because it means they're the same. So we have x plus 9 over x minus 1 equals x plus 3. Common denominator is x minus 1. So now we have x plus 9 equals x squared minus x plus 3x plus 2x minus 3. set it equal to 0. So x squared plus x minus 12. So we've got x plus 4, x minus 3. So x equals -4 or x equals 3. So now we have to check. Let's plug in the -4. Okay, we're going to do the log of -4 plus 9. So that's just the log of 5, so that's good. Minus the log of -4 minus 1. Well, that's -5. Immediately, the minute I have a negative, we cannot do it, does not work. Okay, so that one's bad. So let's try x equals 3. So we do the log of 3 plus 9, which is 12, so we're good there. Minus the log of 3 minus 1, which is 2, so we are good there, equals the log of 3 plus 3. Well, I know subtraction means division, so we're doing the log of 12 divided by 2 equals the log of 6. So the log of 6 equals the log of 6. Check. X equals 3 is my solution. Not bad, but don't forget to check. It's very important on those. All right, let's go to some money now, because everybody likes to learn how to make money. How long to the nearest tenth of year will it take $1,000? So I know my principal is $1,000 to grow to, means I want to get to, so that's my A, 3,600 at 8%, so I know my R is 0.08. Annual interest compounded quarterly, so quarterly, so N equals 4. So I'm trying to find T. We do not know what that equals. So let's go in here and see if we can figure this out. So 3,600 equals 1,000. 1 plus 0.08 over 4 to the 4t power. This is 0.02. Let's divide by 1,000 here to get rid of this. So now we got 3.6 equals inside 1.02 to the 4t power. All right, so now I have to get this t out. The only way to do that is with logs. So I'm going to take the log of both sides. So we know the log of 3.6 equals, bring the 4t down, the log of 1.02. I need the t by itself, so I have to divide by 4, and the log of 1.02 since they're all multiplied. We do that on this side also. And our final answer, I got 16.17 years equals t. It said round to the nearest year, if I remember correctly. Nope, it did not. Okay, so 16.17. So we got 16.17 years before we get to $3,600. Okay, pause and try yours. This time it's the adult height of a girl who is X years old. So we know X is age. We know that f of X is percentage of height. So f of X equals 62 plus 35 log of X minus 4. Okay, we want to know when the girl has attained her 97%. So 97% goes here. 62 plus 35 log of X minus 4. So let's subtract the 62. We get 35 equals 35 log X minus 4. Divide by 35. So 1 equals log of X minus 4. Lost my parentheses along the way. Okay, now I've got to solve this thing. I know that this is log base 10. So since this is a number and this is a number, I can rewrite. So 10 to the first equals X minus 4. So X equals 14. So at 14 years old, she will get to 97% of her height. Okay, I hope you did well. Good luck on your homework. Don't forget to post questions on the discussion board.